Hey guys, what's up? Welcome back to the channel. Today we'll be continuing on complex numbers part 2. Today we'll be performing operations with complex numbers. So addition, subtraction, multiplication, and division. And that will be the end of complex numbers. So let's start off with the easiest of the easy. Addition and subtraction. So I'll start off with addition. When you're adding complex numbers, A and BI are two different variables. It's just like X and Y. This is the real coefficient and this is the imaginary coefficient. Let's say we were adding this with C and DI. BI and DI are like terms and A and C are like terms. So let's just give these variables some numbers now. Let's say A is 1, B is 2, C is 3, and 4 is D. We'll fill it in. Our answer would be 4 plus 6i. Now we're looking at subtraction. Subtraction is the same in terms of like terms, but the only difference is you're subtracting. So it's the same thing really, you're just subtracting. We'll use the same numbers and variables. Subtract C, let's spice it up. Subtract DI equals A plus B I plus minus C plus DI. Let's add in the same numbers here. 1 plus 2I plus negative 3 plus 4. Our answer would be negative 2, oop, I forgot the I here, plus 6i. Before we hop on to multiplication, it's very important to note this detail about complex numbers and I in multiplication. I equals square root of negative 1. If you were to square the square root of negative 1, you would remove the square root and the square, leaving you with negative 1. Keeping I squared in mind, we can now multiply complex numbers. Now, multiplying complex numbers is literally no different from multiplying two different binomials. We're just using the same methods. We could use the FOIL method that we learned in grade 11, or you could use the rainbow method, which is what I like to do. So we'll be multiplying 5 by 2, 5 by 3i, 4i by 2, and 4i by 3i. The rainbow method is very easy for me. Let's multiply this. So some easy multiplication. We get 10 plus 8, 15. And 15 is 23i. Plus 12i squared. So hopefully you're keeping the I squared theory in mind because we have an I squared right here. This I squared can be substituted as a negative 1. Therefore, you're practically looking at 12 as 12 multiplied by negative 1. Negative 1 being the I squared. So this should be actually a negative 12, and that's it. We have the 10 and we got the 23i. We could further simplify this. 10 subtract 12 is negative 2. Our answer, 23i subtract 2. The reason why we get rid of this I squared is because in your final answer, we do not recommend having a power of I 2 or higher. So this is how you do multiplication of complex numbers. In a previous video, we talked a little bit about complex conjugates, and today we'll be applying it to division. Just a review, complex conjugates are when you change the sign of a binomial. For example, here we have 4 plus 2i. The conjugate of 4 plus 2i is 4 subtract 2i. Now, before we multiply, I want to show you something very significant about this. keep into account I squared equals -1. When we multiply the conjugates of these complex numbers, we should get a real number. Let's try it out right now. So we got 16 by 4 times 4. I could already look ahead and see that 2i times 4 and 4 times -2i will be 8i subtract 8i, which cancels out to 0, so I don't need to include it. 2 times -2, -4i squared. We know that I squared is actually -1, so this becomes 16 plus 4 equals 20. As you can see, 20 is a real number because there is no I beside it. Complex conjugates tie into division statements just like this. Our denominator needs to be a real number, so we can rationalize it by using the complex conjugate only on the denominator by multiplying it by 3 subtract 4i, which is the conjugate of 3 plus 4i. Whatever we do to the bottom, we do to the top. So we also multiply this by 3 subtract 4i. And now it's up to us to do the math. So I did all the work here. I just rainbowed the numerator and I rainbowed the denominator. The denominator becomes a real number at the end because of the I squares. And we got a numerator up here. I cannot simplify this anymore, and this will be your answer to the division statement. Before we end this video, let's review what we learned. We learned how to add, subtract, multiply, and divide complex numbers today. And we also learned the importance of I squared. Tune into the final video on complex numbers, where we will be looking at the quadratic equation with complex numbers. If you liked the video, please spank that like button and subscribe. We'll see you next time.